Thanks to the James Webb Space Telescope and no shortage of hard work, our knowledge of the solar system has once again taken a significant leap forward. Uranus has officially got a new moon, and it's a discovery that stands as a testament not only to the dedication of our finest astronomers, but likewise a wave of technological innovation that's sweeping the world. On the other hand, the event has also served to underscore something that perhaps isn't commonly known. Uranus, despite essentially being in our own backyard, is still almost a complete mystery. Discoveries like the new moon emphasize that we know almost nothing about the ice giant, including how its complex system of 29 moons and 13 rings came to be in the first place. Speculation suggests that Uranus must have undergone some sort of cataclysmic event in its distant past, though what that event was and how it occurred is still very much up for debate. NASA is in the process of sending the first ever mission to Uranus in a bid to answer these questions, and what they find may just force a rewrite of everything we thought we knew about one of our cosmic neighbors. August the 19th saw NASA officially announce that the ice giant Uranus, one of our furthest neighbors, has one more moon than previously thought. The new orbiting satellite has been designated S2025U1, and its presence brings the grand total of Uranus's moons to 29. This may sound like a lot, but Uranus is still only in third place, with Saturn referred to as the king of moons, having a total of 274 orbiting satellites, and Jupiter coming in second with 95. Looking at the specifics, S2025U1 is around 10 kilometers in diameter and sits at 56,000 kilometers away from Uranus's center. So, it is a remarkably small moon, one that you could walk the entire circumference of in a few hours. The modest size is part of the reason how the moon managed to remain undetected for centuries, though there are other factors which we'll dive into shortly. The discovery itself is credited to the Solar System Science and Exploration Division located at the Southwest Research Institute in Boulder, Colorado. One of the lead researchers, Mariam El-Mutamid, explained that it was thanks to 10 long-exposure images taken with the near-infrared camera of the James Webb Telescope. Each long-exposure image lasted around 40 minutes, making the entire process a nearly 7-hour-long ordeal. The results speak for themselves, however, with there being little doubt as to what the faint, barely visible blotch is. Even still, the long exposures were actually taken on February the 2nd, leaving a pretty sizable gap until the official announcement. The delay is due to all other possible explanations being systematically ruled out, leaving the only logical conclusion that Uranus does indeed have a previously undiscovered moon. Additional data is needed to confirm the exact size of it, but it seems fairly certain that this is the smallest yet discovered around the planet. As to where the new moon fits into the grand scheme of things, Uranus is notorious for its moon system being unusually complex, rivaling even that of Saturn. Saturn may have more moons overall, but since so little is known about Uranus, astronomers are left scratching their heads as to how the moons and rings interact, and as to how the crowded network remains so astonishingly stable. Got more on that in a moment. With all that being said, the newcomer moon appears to be the 14th that orbits within the boundaries of the 5 major moons, those being Miranda, Ariel, Umbriel, Titania, and Oberon. More specifically, the new moon orbits between 2 other inner moons, Bianca and Ophelia, with Ophelia being at the very edge of Uranus's outer rings. That Ophelia is in this specific location is significant, and the interaction between the moon and the outer ring is thought to hold major clues as to the intricacies of the overall system. We'll also come back to that later. Now, at this point, it may be starting to dawn on you that it is a little unusual that Uranus managed to have a secret moon for centuries, especially given the enormous advancements in technology. And you'd be right to have those thoughts, and the implications take us into the broader topic at hand here. Mariam El-Mutamid gave an official statement following the discovery, putting a few of the details into perspective. She said, "Through this and other programs, Webb is providing a new eye on the outer solar system. This discovery comes as part of Webb's General Observer program, which allows scientists worldwide to propose investigations using the telescope's cutting-edge instruments. The NIRCam instrument's high resolution and infrared sensitivity made it especially adept at detecting faint, distant objects that were beyond the reach of previous observatories." Looking forward, the discovery of this moon underscores how modern astronomy continues to build upon the legacy of missions like Voyager 2, which flew past Uranus on the 24th of January 1986 and gave humanity its first close-up look at this mysterious world. Now, nearly 4 decades later, the James Webb Space Telescope is pushing that frontier even farther. The Voyager 2 mission mentioned is, as it stands, the only closer look we've had at Uranus, underscoring that despite massive leaps in technology, the planet is still one of the most mysterious in our solar system apart from Neptune. Both of the furthest planets have next to no definitive data catalogued, making the pair nothing more than giant question marks on the solar system's map. But aren't astronomers making observations about celestial bodies much further away? Millions or even perhaps billions of light years? Well, if that's the case, how can we still know so little about planets that are comparatively our next-door neighbors? Well, the simple explanation is that those distant observations are concerning light only, and astronomers are making deductions about faraway solar systems based on context clues. What the James Webb Space Telescope is trying to do is observe Uranus directly, and that is a different story entirely. No matter how powerful the apparatus, it's always going to be a struggle directly seeing a planet 2.8 billion kilometers away, which is exactly why Uranus is such a blank slate. Making matters worse is that Uranus's distance from the Sun makes it very dim, and if there's one thing telescopes need to be effective, it is light. With all that clarified, let's also acknowledge that the situation is changing rapidly. The lack of knowledge about Uranus has become so glaring that NASA is shifting its priorities, with the upcoming Uranus orbiter and probe mission now identified as a top priority. Speculation is that the mission will finally unravel the cataclysmic events that created Uranus's 13 rings and 29 moons, which is regarded as amongst the most pressing questions. We'll get to that mission in more detail and some of the current speculation regarding the cataclysmic events later. First, let's add a little context relating to the fact that as mysterious as Uranus is today, turn back the clock and it becomes apparent that the planet has always been a lightning rod for confusion and controversy. Pretty much since the day it was discovered, no one has really known what to make of a planet that seems to actively resist proper identification. It cannot be understated how much German-British astronomer, composer, and engineer Sir William Herschel contributed to early science. His many accolades include the discovery of infrared radiation, the cataloguing of hundreds of double star systems and thousands of new nebulas, plus the discovery of Uranus and at least 2 of its moons. He was a busy dude. He was also a composer. It was in 1781 that Herschel aimed his telescope out into the cosmos and dared to do what few astronomers did. He looked beyond Saturn. Though it wasn't just because Herschel was ambitious that he decided to look further than his peers, it was because he had built his own enormous custom telescopes. His designs were widely regarded as some of the best in the world at the time, and it was with a 40-foot behemoth of his own making that he spotted 2 moons of Saturn, Enceladus and Mimas. Putting it simply, he was in a unique position to look deeper and further than anyone else, and his ambitions rewarded him with the first glimpses of Uranus. The new planet was confirmed by his peers, but not satisfied with just cataloguing Uranus itself, Herschel continued to study the planet for years after the initial discovery. His persistence was eventually rewarded when he confirmed first 2 moons in January 1787. Those would later become known as Titania and Oberon. For the time being, though, they were simply referred to as the Roman numerals 2 and 4 respectively, and this numbering system itself would be a point of confusion later, with it being unclear as to which moon had which number and if there was any reasoning behind the given order. The dilemma would later be solved by William Lassell, who eventually just numbered the first moons 1 through 4 based on their distance from Uranus. Now, when Herschel discovered the first 2 moons, he insisted that he had seen as many as 6 in total, 4 more than the 2 he had confirmed. He even suggested that he had spotted one of Uranus's rings, and this is where things start to get confusing, especially given that we now know that Uranus does indeed have more moons and does have rings. Unfortunately for Herschel, his ingenuity landed up being his undoing. None of his peers could confirm his findings because none of them had telescopes as powerful as his custom builds, and he would sadly pass away without ever getting vindicated. Or on the other hand, he may have avoided some embarrassment since when additional moons were finally discovered, they didn't match his descriptions. Either way, don't feel too bad for Sir William Herschel. He was not only knighted for contributions to astronomy, he'll also be remembered for building the biggest telescope in the world at the time. He was also succeeded by his son, John Herschel, who was partially responsible for cataloguing 2 more moons. The additional moons, Ariel and Umbriel, wouldn't be made official until 1851, courtesy of the already mentioned English merchant and astronomer William Lassell. It was Lassell that consulted with John Herschel, and the pair decided on the naming convention of Uranus's moons that we use today, which, if you haven't already picked up on it, is characters from the works of William Shakespeare, as well as a poem by Alexander Pope. I picked up on the Shakespeare thing, not the Pope thing. Following these initial discoveries, Uranus took a backseat to the more prominent planets, and no more major discoveries were made for almost another century. It wasn't until 1948 that Dutch-American astronomer and planetary scientist Gerard Kuiper in McDonald Observatory added the 5th major moon, Miranda. There were many more moons still to be discovered, but none of that would happen until the breakthrough of Voyager 2 in 1986. Most of you are already familiar with Voyager 2, but for those that aren't, Voyager 1 and 2 were NASA probes that were launched in 1977. The pair achieved their primary goal of flying by Jupiter and Saturn, after which they were given extended goals of passing by Jupiter and Uranus on their journeys out into interstellar space. It was Voyager 2 in particular that passed within 80,000 kilometers of the ice giant, giving us the only close-up information that we currently have. The information gathered added an additional 10 inner moons and 2 rings, plus it was also the first glimpse ever of Uranus's magnetic field, which it turns out is another bizarre mystery. There is an entirely separate rabbit hole here, which we're not going to delve into too much right now, but the short version is that Uranus seems to have a magnetosphere unlike any other planet, sitting out of alignment with the core, being lopsided, and curving into a corkscrew as the planet rotates. There's also unconfirmed speculation as to why the magnetosphere behaves so unusually, with some pointing to the fact that Uranus is believed to be mostly made up of layers of water, methane, and ammonia. It's also been suggested that the magnetosphere was simply observed at a particularly unusual time and was so bizarre only due to a particularly powerful solar flare. So, let's leave that conversation for a different video and move on to the 1990s, which turned out to be the start of an astronomy revolution. Increased international collaboration, advancements in instrumentation, digital surveys, and new observatories led to a wave of new discoveries, including 2 new Uranus moons, Cythorax and Caliban. The discovery came courtesy of a team led by Brett Gladman and Philip Nicholson at the Palomar Observatory, with the 200-inch Hale telescope doing the heavy lifting. These were the first irregular moons discovered in 1997, and they were far from the last. Following this came a wave of additional new moons between 1999 and 2003, thanks to a combination of ground telescopes, old data from Voyager 2, and the then newly launched Hubble Space Telescope. It seemed like all the moons had finally been accounted for, only for Scott Shepard and his team in 2024 to add yet another irregular moon, thanks to information provided by the Subaru telescope located in Hawaii. Uranus still wasn't done though, bringing us to August 2025 and the latest edition, S2025U1. The name is expected to be changed to something Shakespearean, keeping with tradition, and that covers a condensed version of Uranus's unusual history. Now let's turn our attention to the ongoing mysteries, with the most prominent being the cataclysmic event that created Uranus's moons in the first place. Now, the first bit of context to clear up is that moons vary dramatically in size and shape, with it not being a case of each orbiting body necessarily being a moon as we think of our own moon. Any orbiting body around a host planet is referred to under an extremely broad umbrella of a moon, without regard for how the satellite formed or where it came from. In the case of Uranus, the planet's moons are divided into 3 distinct categories: inner moons, major moons, and irregular moons. To be clear, the inner moons and irregular moons are mostly not spherical in shape, and the irregular moons in particular have broad asymmetrical orbits that have little in common with other moons. We'll get to the question of why very shortly, but let's also establish that apart from the many moons, Uranus also has rings, 13 by the latest count, though this number is by no means set in stone. The rings, like virtually everything else about Uranus, haven't been studied in much detail, so take all the information here with a grain of salt. The important thing to keep in mind is that the rings, inner moons, and regular moons are intricately connected, generally orbiting within close proximity and having gravitational influence over one another. As to how the complex system came about, general speculation is that at least some of the moons and rings, specifically the inner moons, share a common origin. The inner moons appear to have small, dark bodies, which is a characteristic shared with the fragments making up most of the rings. The violent event in question is hypothesized to have occurred around 3 to 4 billion years ago between Uranus and a separate icy protoplanet, one that was developing at the same time as Uranus. Uranus pulled the other celestial body into its orbit, the pair collided in what must have been an extremely violent event, and whatever the other body was, it came out second best. The collision is thought to be the reason that Uranus has a tilted axis, and likewise the reason it's surrounded by rings of debris. Over time, the debris settled into the orbiting rings that we see today, with the inner moons essentially being some of the biggest surviving fragments. The 5 major moons, meanwhile, may have come about as a result of the collision, forming within the debris, or they may have formed separately as part of Uranus's original developmental accretion disk. The factors to consider here are that the 5 major moons are spherical, unlike the inner and irregular moons, and the largest of the 5 major moons, Titania, is 1,578 kilometers in diameter, many times larger than the inner moons. The spherical shape indicates that the moons achieved hydrostatic equilibrium, which, in a nutshell, translates to them having achieved a specific size threshold versus their gravity. As for the irregular moons, in all likelihood most, if not all of these moons, are simply asteroids that were pulled into orbit around Uranus due to circumstances unrelated to the collision. There is the possibility that some were related to the collision, but there is no way to confirm this for the time being. Now on to our next mystery, which concerns the structure of the moon and ring system. With all this talk of cataclysmic collisions, you'll no doubt have noticed that the rings and moons are remarkably uniform and balanced, which almost seems to defy logic. In this regard, we can't really fully explain how the moons and rings interact with another, or how the crowded environment has managed to achieve such an extraordinary balance. The details are just unknown, the logistics an ongoing mystery. What we can do is introduce the concept of a shepherd moon, which likely plays a key part in the arrangement. You'll remember that the moon Ophelia sits at the very outer edge of Uranus's further ring, and it's no coincidence that the edge is so uniform. Ophelia has been sweeping the edge of the ring for millions of years, as have the other moons in various locations throughout the rings, including S2025U1. As to why there seems to be almost no collision between the many orbiting bodies, we'll pass that over to Mark Showalter and Jack Lissor, who were part of a team that spotted new moons in 2023. According to Lissar, quote, "The inner swarm of 13 satellites is unlike any other system of planetary moons. The larger moons must be gravitationally perturbing the smaller moons. The region is so crowded that these moons could be gravitationally unstable. So, we are trying to understand how the moons can coexist with each other. Not all of Uranus's satellites formed over 4 billion years ago when the planet formed. The 2 small moons orbiting close to Belinda, for example, probably were once part of Belinda. They broke off when a comet smashed into Belinda." Showalter then added, quoting again, "The orbits will show how the moons interact with one another, perhaps showing how such a crowded system of satellites can be stabilized. This could provide further insight into how the moon system formed. Refining their orbits could also reveal whether these moons have any special role in confining or shepherding Uranus's 10 narrow rings. These moons are 40 million times fainter than Uranus. The moons are at 25th magnitude and Uranus is a 6th magnitude. They are blacker than asphalt if their composition is like the other small inner moons. So they don't reflect much light. Even with the sensitivity and high resolution of Hubble's ACS, we had to overexpose the images of Uranus to pinpoint the moons." End quote. Keep in mind once again that details we've covered in this video are just speculation, and that the picture of Uranus may change dramatically in the future. The good news is, as touched on, that there are plans to launch a full-blown mission to Uranus, the results of which will likely answer many of the unanswered questions. Completion of the Mars Sample Return Program, which we covered in our Fate to the Mars Rovers video, is still the top priority for NASA. If you're not familiar, the Mars Sample Return Program is the incredibly ambitious mission currently underway, with the final goal to transport samples collected by the Perseverance rover back to Earth. But as of 2022, the need to explore Uranus has also been given center stage, with a recommendation put forward during the 2023 to 2032 Planetary Science Decadal Survey. Consensus at the survey was that the Mars sample return program stay on track, but that all other effort be put toward launching a mission toward Uranus. The mission is currently referred to simply as the Uranus Orbiter and Probe, or UOP, and it's said to be amongst the most ambitious ever attempted. The package will include a delicate orbiter and probe, which will separate after entering Uranus's atmosphere, allowing each segment to focus on specific scientific objectives. The orbiter will be equipped with an array of cameras and other tools, with one of the main focuses being an analysis of the planet's magnetosphere in greater detail. The probe will focus on investigating Uranus's atmosphere, with key equipment on board being an atmospheric structure instrument. Of course, major effort will also be put towards studying the rings and moons, and NASA has publicly released a set of questions they hope to answer in that regard. One particular read, what are the compositions, origins, and history of the Uranian rings and inner small moons, and what processes sculpted them into their current configuration? It's also been specified that the orbiter will achieve a close quarters flyby of each of the 5 major moons, meaning that real answers to the many mysteries is just a matter of time. The launch package of UOP is set to include the 60-kilogram orbiter plus the 19-kilogram atmospheric probe, with a total launch mass of over 2,000 kilos, including fuel. It all sounds rather exciting, and UOP is certainly set to be a groundbreaking mission in almost every regard. The bad news is, you're gonna have to wait a little bit of a while. Although the mission is confirmed and very much in development as we speak, keep in mind that Uranus is over 2 billion kilometers away, and that means buckling in for the long haul. Initial suggestions were that a launch be planned for 2031, but this date was later moved forward to late 2030. So the launch itself may only be a few years away, but travel time is expected to be anywhere between 12 and 15 years. The package is expected to fly by Jupiter around 2035 and arrive at its final destination around 2044. We can, in the meantime, watch the Mars sample return mission unfold, which may be seeing major developments as early as next year. We'll keep you posted, and thanks for watching.